Hello and welcome everyone to the demo of deploying drone telemetry and control application on Edge Cloud using our in-house end-to-end orchestration framework. What is this demo about? In this demo, I will give an introduction of our in-house end-to-end orchestration framework. To demonstrate the usage of the framework, I'll orchestrate a microservice-based application. Once the application is orchestrated, I will show how we are monitoring the application KPIs. Who would be interested in this video? The verticals planning to roll out applications for edge deployment, and academic and industrial communities working towards network slice orchestration. Any prerequisites here? Yes, it will be nice if you are aware of these topics: network slicing and orchestration, ETSI multi-access edge computing, ETSI Mano, and ETSI IFA 029 document. And the fourth is container orchestration system like Kubernetes and OpenShift. I'll start with the global picture of the whole end-to-end orchestration. On the topmost is the vertical user plane, a vertical which wants to deploy a network slice. This vertical user will only use the web portal to interact with the framework, and the rest of the part is abstract to avoid complications for the users. The verticals will provide a network slice template. This template will be passed by Slice Orchestrator in two parts: RAN and network service descriptor. Each descriptor will be sent to its orchestrator. RAN descriptor to RAN orchestrator and network service descriptor to NFV orchestrator. The infrastructure plane is the part where actual action takes place. Here, our platform provides the possibility to orchestrate the virtual network functions or Mekki applications on two different container orchestration systems like OpenShift or vanilla Kubernetes. The NFV provides the possibility of DNS redirection for Mekki applications via communicating with mobile edge platform. Now let's move forward towards the demo. In this demo, I will demonstrate the working of our in-house tool by deploying a drone telemetry and control application. For this demo, I will be using simulated drones. These drones behave like actual drones with simulated data. In case of a central and edge cloud deployment, the core network components can be present at the central cloud, and at the edge cloud, there is our orchestration framework and its components. The mobile edge platform and radio network information service, which provides real-time RAN information of user equipments connected with the network. Then at the edge cloud, we will orchestrate the drone telemetry and control application, which will consist of three components. First, southbound facing the mobile network getting drone telemetry information. Second, database where drone telemetry information will be stored. And third component will be northbound, which will be hosting a graphical user interface which will represent all the information collected from drones and RNIS API. In this demo, I will not be orchestrating a RAN subslice. It will only be a network service subslice which consists of this application. The RAN slice orchestration is a big topic and it will be covered in another separate video. Let's go ahead with the demo. I'll start with showcasing our web portal, which will be used by the vertical users. As you can see, it's quite simple and it has minimalistic features. I'll start with logging in the web portal with an account which is already created. Now I am in the web portal. I'll start with creating a network slice. So while creating a network slice, the important part is the name of the network slice, the provider, and then the type of the network slice. So the type of the network slice in this demo I will not be using, so we can choose any of the type of the network slice. And since I need the KPIs for this slice, so I'll enable the KPI monitoring. Now the RAN subslice. Since in this demo I will not be showcasing the RAN subslice, but as you can see the information which is needed to make a RAN subslice. I'll start with making a network service subslice. For that, there are two options, either to upload or create it manually. I'll show how to create it manually. So to create it manually, we need the network service descriptor's name, the name of the application in the network service descriptor, then its resource requirement like the CPU, size, and RAM, and the image URL, meaning that where exactly the image of this application is hosted. So let's say if the application also needs some configuration information, so we can add some configuration parameters. And if it needs to expose some post towards, let's say towards internet or mobile network or cloud or container network, that is also possible. And the type of protocol which you would like to use, let's say TCP or UDP. Now the domain name is the domain name which the application would like to use at the time of DNS redirection, which I was talking about it earlier. Since creating a NST manually it's a time-consuming task. For this demo, I will start with uploading an NST which is already created in a JSON format. I'll showcase this later in the demo. I'll start with validating this JSON file, and this step it will parse and show the applications which are there. There are 3 applications, and now I'll choose the Vim for this demo. Now the application is in the creation phase. While the application is being created, I'll show the NST which I used for creating this slice. So in the NST, so this NST, it's been inspired from the application descriptor appd, which is covered in the ETSI Mekki, but it's not following exactly the appd. It has taken some paths from it. In this, you can see there are there's a description for different applications. Our GPS outbound, northbound application. It's a resource, every component's resource consumption, and the URL of where the image is being hosted. Here, the image is being directly fetched. The code is being fetched from GitLab, and we will make the image using our framework. And here is and in the case of database, the image is present in a public repository, and it will be fetched directly from the public repository. Since the slice creation takes some time, if you want, you can move forward in the video. So now the slice is created. As you can see, it took around 96.75 seconds to create the slice. I'll show the network instance information. So this URL is the URL to reach the northbound application, which is hosted by the northbound component. Then this IP address is the IP address of the southbound component, which can be reached from the drone, and it is using the DNS redirection as I showed earlier. So this DNS name will be configured in the drones so that they can send their information to the southbound application. This is the monitoring information, which we will see later. Now let me show you this northbound GUI. So this is the GUI. It takes some time for the drone to be configured and for our simulated drones to get configured. As you can see, now they are configured. The data is coming. So this is the IMSI. This is all simulated data, but this is actual simulated data. You can see that the latency, the altitude, slowly and gradually the altitude will change as the drone is getting ready. As in a while, the drones will get ready, and now you can see that the altitude information is changing, and they are started moving, and all this information is being pushed towards the southbound component, and then the southbound component will save all this information in the database, and it's being fetched by the northbound component, and as you can see, that information is reflected to you using this GUI. Now I'll start with showing the monitoring information using Grafana. So in Grafana, as you can see, it has So here you are seeing the total consumption of the three components of the all the three components, the consumption of the CPU and the RAM. There are these graphs to understand in a better way that how the application is performing, and here you can see the consumption of each application. So that was the collective consumption, and here it's application-wise consumption. And this you can see using using these graphs that how it is performing in a particular interval. And here is the RAN KPIs. Since we are not using any RAN part here, so that's why there is no RAN KPI. Here we have provided another way of fetching the KPIs using RabbitMQ, and here it's a raw KPI. So these raw KPIs earlier, those KPIs were being reflected using Grafana, but in the raw method, you can just fetch these KPIs and use them for analytical purposes. Let's say for some, let's say you will use your own algorithm to extract some information, or you would like to make your own dashboards. So it is better to extract the raw information. Now I'll start with stopping the slice. For that, I'll click on the Stop Slice button. Stopping the slice also takes some time. So while the slice is being stopped, if you want, you can move forward in the video. And there is another feature which you provide is updating the slice. That means you can update the resource consumption, the resource requirement of each application component. Now the slice is stopped. Either we can redeploy it or we can delete the slice. I'll go ahead with the slice deletion. The slice is being deleted. So in the deletion phase, what it does is that it removes all the images and all the configuration and removes all the data which is stored in the database. The slice is deleted. Thank you so much for watching the video, and if you have any questions, please write us.